Okay, so now what we're going to do is working on solving equations. So when you solve any equation, basically you're trying to make or find the values that make the statement true. Okay? Okay, so this could be just one value, or it could be two values, or it could be an infinite number of values. It could be, you know, three values. So oftentimes what you will find when you solve a trig equation is you will find a statement that looks like this. Find the values for x for the values 0 to 2 pi. So that means you're going to find it for the normal period of sine and cosine. Okay. Now remember, the period of tangent is actually pi. Okay. So you have to be careful with that. Also, they can actually change the period. Okay. So you actually might be finding more solutions than you expect. Okay. So just be careful. You will get used to it. It's not a big deal. Okay. So we're going to keep our solutions now from 0 to 2 pi. Okay. And then I'm going to do an infinite solution one. Okay. So I'm looking at this equation going, okay, what do I see? I see sine. Oops. Get rid of that. Okay. I see sine of x plus 3 plus sine of x minus 3 is equal to 1. So I still have to find out what x is. So let's use my sum and difference formulas to see if I can get a little help. Because right now, not much I can do. All right, here we go. Again, I'm just using the formulas, using the identities. Okay, now since I'm not proving things equal, I do have all of the properties of equality, so I can move stuff around. This is an equation. It's not proving an identity. Those are two different things. Okay, so now I'm going to look on my unit circle and say, okay, well, what's cosine of pi over 3? What's sine of pi over 3? See if replacing those can help me out. So cosine of pi over 3 is 1/2. Sine of pi over 3 is radical 3 over 2. Okay, so now I'm going to look for like terms. Okay, so this is like, and this is like. Notice they are opposites, so I can actually cancel those out. Now I've got another set of like terms. Got these. So I have, let's write that out. Sine of x over 2 plus sine of x over 2 equals 1. So sine of x over 2 plus sine of x over 2 is sine of x. Okay, so I have sine of x is equal to 1. So there's basically a couple different ways you can handle this. You can use a calculator, okay, or you can break out that unit circle that we used last semester, and you can ask yourself, okay, since I'm looking for values of x between 0 and 2 pi, you can say, okay, where on my unit circle does sine of x give me a 1? And that happens at pi over 2, and that's it, okay? Okay, or if you use sine inverse, which you can totally do, it's going to look like this. Now you got to be careful with using the inverses, especially on a calculator. Okay, because if your calculator's in degrees, it's going to kick out a 90 degrees rather than a pi over 2. Um, Also, it obeys the ranges of sine inverse and cosine inverse. If you remember from last semester, the range of sine inverse is negative pi over 2 to positive pi over 2. It's only going to give you one of the answers when you may actually have multiple answers. Okay, so let's try another equation. Okay, let's try a second one. And these do, guys, take a little bit of getting used to. Okay, I have confidence in you. Okay, but they do they do test your abilities. Okay, so again, we're going to use the sum and difference. Okay, so this one's going to be interesting because it has tangent in it. Okay, let's see what happens. Well, we have two choices. Okay, remember we do have a lovely, lovely kind of sum and difference identity for tangent. Also, I know that tangent is equal to sine over cosine. Okay. I also know okay, that might be a little easier. Okay. So what I'm going to do is I'm going to do this. I'm going to go 2 sine x plus pi over 2, just like that, plus 3 tangent. Whoops, let's change the tangent to sine pi over cosine. Just like that. Okay, that is completely legal. Okay, looks a little different, but we can do it. You can also keep the tangent if you'd like. So let's use my sine and cosine sum and difference to help me out. So let's see. Okay, so there's the first one. Okay, second one. Again, I'm just rewriting. It just takes a really, really long time to rewrite it. Oops. And again, if you want to have a formula sheet out by you while you do this, that's perfectly fine. I have one next to me. Okay, here we go. All right, so we have to ask ourselves what's cosine of pi over 2? What's sine of pi over 2? Okay, so cosine of pi over 2 is actually 0. And then cosine x times sine of pi over 2, that is 1. Okay, so this right here is going to go to 0. That's nice. Okay, let's look at the next bit. Okay, sine of pi is 0. Cosine of pi is -1. Okay, so you'll notice that a lot of stuff is going to 0. Okay, so let's just work it. So this first part just becomes 2 cosine x. The second part becomes sine x over negative cosine x equals 0. Let's see here. So now, common denominator sounds like a good idea. So okay, so now what we want to be sure of, let's see, what could we do? It'd be really nice if we could get everything in terms of sine, right? So let's think about, remember this guy? He's kind of your best friend. Okay. So let's do a little bit of a replacement. Check that out. -2. Again, I'm just solving the equations. I'm not doing anything, really weird. So combining like terms. Oops. Okay. All right, so we got an interesting thing going on here. We have a rational function, which means a fractional function, with sine and cosine. Okay, so what we want to do is we want to figure out where the top is equal to 0. Okay, but we also want to know where the bottom equals 0, because that's going to tell us if we have any domain issues. Are we going to have places where my equation is undefined? Okay, so here we go. Let's deal with the top. And then deal with the bottom. Okay, remember, we're trying to find values between 0 to pi over, or excuse me, 0 to 2 pi. So cosine is 0 at x equals pi over 2 and 3 pi over 2. So that's what x can't be, okay, because that would give me a 0 on the bottom. Okay, so let's work on this one. Add the 2 to both sides. Divide by 5. Okay, now you're going to do something weird. You're going to take the square root. Okay, so when you take the square root, you actually get two things. You get positive square root 2 over 5, and then negative square root 2 over 5. Okay, now these are not on the unit circle, are they? No, they're not. So what you're going to have to do is you're going to have to use your calculator. You have to use that sign inverse button. Okay. Oops. All right. Oops. It'll help if I press the right buttons, huh? Okay, so I get then okay. Now, if I want values between 0 and 2 pi, okay, which is 6.28, which I'm going to have to do is I'm going to have to add 6.28 to see what my answers are. Okay, here we go. Let's do the negative one first. Okay, so that's going to give me so that's one. Okay, and then this one's going to go over, so I'm just going to keep this one. Now again, I want to make sure that that is our values that I can keep. So I'm going to check those against pi divided by 2, which is good, and then 3 pi divided by 2, and that one's good as well. Okay, so these are and can be a little complicated, and they can be a little bit long. Okay, so don't worry about it. Go slow. Okay, you'll get used to it. Okay, you can also solve these by graphing. Okay, all right, so we'll work on solving them graphically as well.